Welcome to the lesson, Safety Features and Protections in Hydrogen and Fuel Cell Vehicle Systems. In this lesson, we will focus on how fuel cell vehicles, facilities, and technicians work together through design, monitoring, procedures, and standards to safely manage hydrogen, electrical, and fire-related risks. Let's look at our lesson objectives. By the end of this lesson, you will be able to explain how layered safety systems in fuel cell vehicles continuously monitor and respond to abnormal conditions. You will also describe hydrogen leak prevention and detection strategies used in vehicle and facility design. Then, you will identify fire prevention, fire response, and pressure management features within hydrogen fuel cell systems. Following this, you will learn to recognize electrical safety protections and the personal protective equipment required for fuel cell vehicles. Finally, you will be able to describe safe work practices, facility requirements, and regulatory standards related to hydrogen systems. Fuel cell vehicles rely on multiple layers of safety working together. Engineers design these vehicles to prevent problems before they occur. These systems operate continuously in the background, monitoring conditions such as hydrogen concentration, pressure, temperature, and electrical status. If an abnormal condition is detected, such as a leak, overheating, or unsafe pressure, sensors and control systems respond automatically to reduce risk, isolate the system, or shut it down. Together, these built-in protections help prevent accidents before they escalate and ensure the vehicle meets strict federal safety requirements. Engineers design fuel cell vehicles to minimize leak risks from the start. They select materials that safely handle hydrogen without weakening over time. Designers route hydrogen fuel lines away from passenger areas to prevent leaks from entering occupied spaces. For a fuel cell transit bus, storage tanks are mounted on the roof, allowing any released hydrogen to rise and disperse safely into the air. Ventilated enclosures around fuel cell systems continuously draw air to prevent gas buildup. These design features reduce risk before sensors or alarms are ever needed. Hydrogen leak detection systems are very important for keeping fuel cell vehicles safe. These systems use several sensors. Sensors are electronic devices that detect hydrogen gas in the air. Engineers place the sensors in areas where leaks are most likely to happen or where hydrogen could collect. In fuel cell cars, buses, and trucks, hydrogen sensors are installed near storage tanks, along hydrogen lines, around the fuel cell system, and in enclosed spaces where hydrogen could accumulate. The sensors constantly check the air and measure how much hydrogen is present. As hydrogen levels increase, the system gives stronger and stronger warnings. When hydrogen reaches 0.2%, the driver receives an early warning. If levels rise to 0.6%, a second warning appears. At 1% hydrogen, the system sounds an alarm and automatically shuts down the fuel cell system. During shutdown, valves close to stop the flow of hydrogen so the leak cannot get worse. These warnings happen long before hydrogen reaches dangerous levels. The dashboard shows warning lights, messages, or gauges that display hydrogen levels so the driver can respond quickly. When the vehicle is parked and turned off, the onboard leak detection system may switch to a low power mode or shut down to save battery power. However, hydrogen can still leak from a parked vehicle. Because of this, parking garages and maintenance facilities that store hydrogen vehicles must have their own leak detection systems that stay active at all times. If a hydrogen leak is detected, what should you do? There are specific procedures to follow to safely stop the leak. When a leak occurs, safety procedures guide every response. Technicians must move to open or well-ventilated areas to allow hydrogen to disperse safely. They must remove ignition sources to prevent fires or sparks. Trained personnel must use approved tools to locate leaks without endangering themselves. Before returning the vehicle to service, the teams must confirm that repairs were successful and that the system operates safely. They must document everything they've done. These steps protect both people and equipment. Just as with leak prevention, fire prevention starts with smart design. Let's look at the design features that reduce fire risk. Fuel cell vehicles include features designed to prevent fires from starting or spreading. Grounded metal components prevent static electricity from creating sparks. A pressure relief device is a safety valve that automatically releases gas when pressure exceeds a set limit. Pressure relief devices protect storage tanks by safely releasing hydrogen if temperatures rise too high. Venting systems guide released gas upward where it disperses quickly. Fire detection systems in vehicles and buildings help identify problems early, enabling a fast response. Facilities where hydrogen vehicles are fueled or vented require their own fire safety infrastructure. The facility must be properly grounded and bonded to the vehicle during fueling to prevent static discharge. The facility must also have fire detection systems to identify fires early and fire extinguishing systems appropriate for hydrogen fires. These facility requirements are just as important as the vehicle safety features. If a hydrogen fire occurs, proper firefighting procedures are critical. Let's walk through the approach for different fire sizes. When a hydrogen fire occurs, responders focus first on stopping the fuel supply. Without hydrogen, the fire cannot continue. Small fires may be controlled using approved methods, but responders must remain cautious of reignition. Larger fires require cooling nearby equipment to prevent damage and spread. If a fire becomes uncontrollable, responders must evacuate the area and manage the situation from a safe distance. Protecting people always takes priority. Always remember, in case of any emergency, if you are in the United States, call 911 immediately. High-pressure systems require multiple layers of protection. Let's look at the safety features that protect against pressure hazards. Fuel cell vehicles store hydrogen at high pressure, so safety systems carefully manage that pressure. Automatic valves isolate hydrogen when the vehicle shuts down or when a collision is detected. Flow-limiting devices limit the amount of gas that can escape if a line breaks. Pressure relief systems protect components by safely releasing pressure. Regular inspections ensure all pressure-rated components remain reliable and safe to use. Electrical safety in fuel cell systems involves both physical barriers and active monitoring. Let's look at each protection. Fuel cell vehicles generate electricity, making electrical safety essential. High-voltage protective barriers prevent accidental contact with high-voltage parts. These barriers are made of non-conductive materials and are designed so you cannot accidentally touch a high-voltage component during normal operation. Energy dissipation systems reduce leftover electrical charge after shutdown. Monitoring systems detect electrical faults that could cause shock or damage. The ground fault monitor will trigger a warning or alarm if it detects a ground fault, alerting operators to the problem. Manual Service Disconnect, MSD, allows trained technicians to safely isolate electrical systems during maintenance or emergencies. Personal protective equipment is your last line of defense. Even with all safety systems and procedures in place, technicians must wear PPE when interacting with fuel cell systems. Let's go through the required PPE and understand why each piece is important. Eye protection guards against splashes and debris. Gloves and protective clothing prevent skin exposure to system fluids. Safety footwear protects against heavy components. Removing metal jewelry reduces the risk of electrical burns or short circuits. PP adds a critical final layer of protection. Let's understand the essential safe work practices that every technician must follow. Always work in well-ventilated areas, preferably outdoors, or in facilities designed for hydrogen work with proper ventilation systems. Good ventilation prevents hydrogen accumulation and helps dissipate any chemical vapors. When fueling, venting, or performing any maintenance on hydrogen systems, follow the manufacturer's procedures exactly as written. Don't take shortcuts or improvise. Before operating any fuel cell system, verify that all high-voltage barriers and covers are properly installed. When working on electrical systems, always verify that the voltage is zero with appropriate testing equipment before touching any component. Don't assume that the voltage is gone just because the vehicle is off. You must always verify it. Use insulated tools when appropriate. Keep one hand behind your back when testing to prevent current from flowing across your heart, and never work alone on high-voltage systems. Never tighten any fitting while it's under pressure. The combination of internal pressure and the mechanical stress of tightening can cause the fitting to crack or shatter. Never loosen a fitting without first venting the circuit to atmospheric pressure. A pressurized fitting can become a projectile when loosened. Always follow proper venting procedures to safely release pressure before opening any connection. Pay attention to warning decals. If a decal warns of high temperature, wait for the component to cool before touching it. If it warns of high voltage, treat that area as electrically live until proven otherwise. Lockout and tag-out procedures prevent systems from turning on unexpectedly during maintenance. When moving heavy components, properly secure them to the lifting equipment. Inspect straps, chains, or hooks before lifting. Take your time and don't rush, as most accidents happen when people hurry and skip safety steps. Facilities that store or service fuel cell vehicles play a major role in safety, so it's important to understand what makes a space safe for hydrogen work. Vehicle leak detection systems may be inactive when the engine is off, yet hydrogen can still leak from a parked vehicle. For this reason, parking garages and maintenance facilities must have independent leak detection systems that operate continuously even when vehicles are unoccupied. Sensors should be placed throughout the facility, especially near ceilings where hydrogen can accumulate, and tied to alarm systems that alert facility personnel when hydrogen is detected. Fire detection is also critical. Facilities housing hydrogen vehicles typically use smoke, heat, or flame detectors connected to the building's fire alarm system and, in some cases, automatic fire suppression. The goal is early detection, identifying a fire while it is still small and manageable. Fueling facilities have additional requirements because high-pressure hydrogen is handled directly during fueling. Comprehensive grounding is essential. Grounding means electrically connecting metal parts to prevent the buildup of static electricity. Fueling areas must be well ventilated, most often outdoors or indoors with robust ventilation and equipped with fire detection and suppression systems designed for hydrogen, along with trained personnel. Maintenance facilities also require proper infrastructure. Concrete floors are preferred over asphalt, and drip pans should be used to capture spills. Ventilation is critical, including both general airflow and local exhaust at work areas, to direct any released hydrogen toward exhaust points and away from occupied spaces. Codes and standards from government agencies and industry groups ensure that hydrogen systems are designed safely and maintained properly. Emergency responders are trained to act quickly and correctly if something goes wrong. The Occupational Safety and Health Administration, OSHA, has established standards to ensure hydrogen is handled safely in workplaces where it is stored, transferred, or used. Standard 1910.103 outlines how hydrogen systems must be designed, installed, and operated to reduce the risk of leaks, fires, or explosions. Employers are required to develop written operating procedures so workers understand how to safely work around hydrogen systems, and they must keep hydrogen areas free of combustible materials that could increase fire risk. In addition, facilities must follow OSHA's emergency action planning requirements under 1910.38 and comply with the compressed gas safety rules in 1910.101 to ensure workers know how to respond quickly and safely in the event of an incident. Let's look at the summary for our lesson, Safety Features and Protections in Hydrogen and Fuel Cell Vehicle Systems. Fuel cell vehicles are designed with multiple layers of safety that always work together to reduce risk. These systems monitor hydrogen levels, pressure, temperature, and electrical conditions, allowing potential problems to be detected and controlled before they become dangerous. Hydrogen safety begins with smart design choices, such as proper material selection, ventilation, and strategic sensor placement, which help prevent leaks and ensure rapid detection if one occurs. Fire, pressure, and electrical hazards are further controlled through grounding, pressure relief devices, automatic shutoffs, and protective barriers. Even with these systems in place, technician actions remain critical. Safe work practices, personal protective equipment, facility safety infrastructure, and compliance with OSHA and industry standards ensure that both people and equipment are protected throughout the vehicle's life cycle. Thank you.